Assalamu alaikum dear students. In previous lecture we discussed the composition of two functions. That is, if we have two functions f from a to b and g from b to c, then we can define the go g or f of x, and it is a function from a to c. Now today we are going to discuss the same topic. Now let me consider an example or two functions f from set 1 3 4 to 1 to 5. So here a is 1 2 3, b is 1 to 5, 1 to 5, and g from 1 to 5 to 1 3. That is, g is the function from set b. Set b is here 1 to 5, 1 3. And these two functions are defined as f equals to ordered pair 1 2 3 5 and 4 1. Now this is clearly the function because no two ordered pairs in this f have the same first entries, and this domain of this f is set 1 2 3. That is why this is a function, or this is a tabular representation of the function from 1 3 4 to 1 2 5. Now similarly, g is defined as 1 3 2 3 and 5 1. This means that when 1 2 ordered pair belongs to f, so f of 1 is 2, f of 3 is 5, f of 4 is 1, g of 1 is 3, g of 2 is 3, and g of 5 is this 1. So here this function f and g, the codomain of f equals to the range, or simply the range of this f equals to domain of g. This means that here we can define this GOF, and GOF is function from this a means 1 3 4 to c, which is 1 3 in the definition. So it is a function from 1 3 4 to 1 3 defined by GOF of x. GOF of x equals to g of f of x. Now here the domain of this GOF means GOF function is 1 3 4. So GOF of 1 equals to g of f of 1. Now f of 1 is here as given in f is 2. This means that here we get g of 2, but g of 2 is here 3, which implies the 3. Hence GOF of 1 equals to 3. Similarly, GOF of 3 equals to g of f of 3. F of 3 is this 5, g of 5. G of 5 is here 1, so this means that it is 1. Similarly, you can have g of f of 4, which is g of f of 4. F of 4 is 1, it is g of 1. G of 1 is here as defined in g, it is 3. This means that 1 through this GOF is related with 3, 3 is related with 1, and 4 with the 3. Hence, GOF is actually ordered pair 1 3, 3 1, 4 1. So this is the composition of these two functions. Here we cannot define the fog FOG because domain of this first function not equals to, or simply codomain of the first not equals to domain of the second function. Now if we have the functions in the analytic form, like f of x equals to mod x, g of x equals to mod 5x minus 2, we have to find, here we can find GOF, we can find fog, because it is understood here that the domains and the ranges of these two functions are equal, codomains are equal. It is not here mentioned, the domain and the codomain. That is why we can define here fog as well as GOF, but here in this domain as well as range codomain are defined. This means that we can define only those things which satisfies the given condition. Now here we can define f of g means fog. The fog of x equals to f of g of x. Now g of x is defined as mod 5x minus 2, that is f of mod 5x minus 2. Now here f of x is defined as mod x. This means that if we put x to be mod 5x minus 2, it is mod of mod 5x minus 2, because here x is mod 5x minus 2, f of x is mod x. That is why f of 5x minus 2 is mod of mod 5x minus 2. Now mod of positive is again positive, it is simply mod 5x minus 2. So this is here fog. Now GOP is g of f of x. Now f of x is mod x. Now g of x is mod 5x minus 2, which implies that g of mod x is mod of 5 mod x minus 2. Now clearly here you can check for negative as well as for the positive values. Of course, for positive the value is same, but for negative real numbers, negative real, mod of 5x minus 2 is not equals to mod of 5 mod x minus 2, because if we put x to be minus 1, mod of 5 minus 1 minus 2 is simply minus 7, that is 7, while as this is 3. This means that f of g is not equals to g of f in general. Hence we from this example we can say that the composition of two functions is not in general commutative, that is f of g not equals to g of f in general, but addition algebra is always commutative. Now similarly, if we consider f of x is 8x cube, g of x is 8 raised to power 1 upon 3, x raised to power 1 upon 3, then f of g of x equals to f of g of x, which is here g of x is x raised to power 1 upon 3. This means that it is f of x raised to power 1 by 3 by replacing g of x by x raised to power 1 by 3. Now here f of x is defined as 8x cube, while as f of x raised to power 1 by 3 is replacing x by x1 by 3, that is x1 by 3 raised to power cube. Now cancelling this 3 and 3, simply we get 8x. And g of f of x is g of f of x. G of x, f of x is 8x cube, so it is g of 8x cube. Now g of x is x raised to power 1 upon 3, it is 8x cube whole raised to power 1 upon 3. Now 8 is 2 cube, x cube whole raised to power 1 by 3 by index law. This 3 cancels, so we simply get 2x. Hence f of g is, that is fog is 8x, GOP is 2x, which implies that fog not equals to GOP. Now here we have an important remark, that if a function from a to b and g is the function from b to c, or one functions, or it is given that these two functions are one functions, then we have to prove that this g or f, because here we can only define g or f means GOP, because here GOP is the function from a to c. We can define here the GOP is one function. We have to prove that this GOP is one function. Now here f is a function from a to b, g is function from b to c, or one functions, then by definition f of x1 equals to x2 implies x1 equals to x2 for all x1 x2 belongs to a, because f is 1. Similarly, if we consider elements of g, these b to be y's, then g is 1 implies that g of y1 equals to g of y2, which implies that y1 equals to y2 for all y1 y2 belongs to b. Here we can define only GOP because you know it, but not fog. So GOP is a function from a to c. We have to prove that this GOP is one function. Now how to prove one function? If we have a function which we have to prove that this is one, so we consider two elements from its domain, or simply an arbitrarily two elements, such that f of x1 equals to x2 implies that x1 equals to x2. Here domain of this GOP function, that is this g of f is a. Elements in a are of the form of x1 x2 x3. To prove g of f of x1 equals to g of f of x2 should imply that x1 equals to x2, then we say that this GOP is 1. Now if we consider two elements x1 x2 belongs to a, because domain of this GOP is a. Now suppose that g of f of x equals to g of f of x2. Now by definition of GOP, it is g of f of x1 equals to g of f of x2. Since g is 1, g is 1, f of x1 and f of x2 are the elements of the domain, because by definition which implies that when g is 1 1 implies that f of x1 equals to f of x2. Now again here f is 1 1 implies that x1 equals to x2. Hence this GOF of x GOF of x1 equals to GOF of x2 implies that x1 equals to x2. So by the definition of this 1 1 function, this GOF function is 1 1 function. So we can say that if we have two functions, f from a to b, b from this g from b to c, then GOF is this 1 1 function, or in other words, composition of two 1 1 functions is a 1 1 function. So inshallah in tomorrow's lecture we will discuss this, if we have two onto functions, then what can we say about GOF, and if GOF is 1 1, what does it imply, whether both functions are 1 1 onto or not. So thank you.